Hello, math friends. This is Pre-Calculus, section 6.2, day 1 notes. Today we are going to start by reviewing a little bit of SOHCAHTOA, our right triangle trig, which we hopefully learned in geometry and already reviewed a little bit last chapter in chapter 5 when we were looking at those angles and ordered pairs on the unit circle. So first of all, we have our acronym SOHCAHTOA, which I like to write like this. And that helps us remember our right triangle trig. And the SO stands for the fact that sine of theta is equal to the side opposite of theta over the hypotenuse. Cosine of theta is equal to the side adjacent to theta over the hypotenuse. And tangent of theta is equal to the side opposite of theta over the side adjacent to theta. And again, this all hinges on which angle we call theta. So obviously, in our picture here, this is our angle theta right here in the lower right-hand corner. But we could just as easily change theta to be the angle in the upper left-hand corner, which would change all of our ratios. So you always have to keep in mind your reference point. Where is theta, or which angle in your triangle is theta that we are talking about? Cosecant, secant, and cotangent are just the reciprocals of sine, cosine, and tangent. So if sine of theta is opposite over hypotenuse, cosecant is the reciprocal of sine, so that would be the hypotenuse over the opposite. Secant is the reciprocal of cosine, so that would be the hypotenuse over the adjacent side. And cotangent would be the reciprocal of tangent, so that's going to be the side adjacent over the side opposite. So in our first example, we have a triangle. Theta has been labeled for us. It is the angle in the lower left-hand corner. And you can see that the three sides of the triangle are 6, 8, and 10. Hopefully, some of you are already thinking, hey, wait a minute, that's a special triangle. That's a 3, 4, 5 right triangle. It's just that our side lengths have been doubled. So to save ourselves the pain of reducing all of our trig ratios every time, let's just go ahead and let's rewrite the lengths of our sides as 3, 4, and 5, because when we do our trig ratios, then they will already be in their most reduced forms. All right, so we're starting with sine theta. We know sine is the side opposite over the hypotenuse. The side opposite of theta is 4, and the hypotenuse is 5. So sine of theta is going to be 4/5. Therefore, the reciprocal of sine, cosecant, would be 5/4. Cosine is adjacent over hypotenuse, so in my triangle, that is going to be 3/5. Secant is the reciprocal of cosine, so that would be 5/3. Finally, tangent of theta is the side opposite over the side adjacent. So in this case, it's going to be 4/3. And cotangent would be the reciprocal of tangent, so that side would be 3/4. Moving on to our next example. If cosine of theta is 5/7, sketch a right triangle with an acute angle theta and find the other 5 trigonometric ratios. It's given to us that cosine of theta is 5/7. So we're going to call this angle right here theta. And I know some of you are thinking right now, well, how do you know it's that angle and not the other one? Honestly, it doesn't matter, okay? It's arbitrary because this is just a picture that we're using as a reference. So if we call this side theta, we know that cosine of theta is 5/7, but we also know that cosine is adjacent over hypotenuse. So that tells us that the side adjacent to theta has to be 5 and the hypotenuse has to be 7. And again, we got that from the given information in the problem. So now if we want to find the other leg of our triangle, which we're going to need to do in order to find the other 5 trig ratios, since this is a right triangle, we can use the Pythagorean theorem. We know that a squared plus b squared is equal to c squared. So in this case, 5 squared plus b squared, and again, we don't know what our b is there, that other leg, is going to be equal to 7 squared. So we can go ahead and do the math here. This will be 25 plus b squared is equal to 49. If we subtract the 25 over to the other side, then we'll have b squared is equal to 49 minus 25. So we end up with b squared is equal to 24, but again, we have to square root both sides. So that tells us that b is going to be equal to the square root of 24, which can be simplified. There's a perfect square in 24. So if we separate 24 into square root of 4 times square root of 6, b is 2 square roots of 6. All right, so now we can take that information and we can add that to our picture right there, because we know that b is equal to 2 square roots of 6. So now we are able to find all of the other trig functions because we have all three sides of our triangle. Sine is opposite over hypotenuse. So in this case, sine is going to be 2 square roots of 6 over 7. Cosecant then is going to be the reciprocal of sine. That's going to be 7 over 2 square roots of 6. But now we run into a problem because we know that we can't leave a radical on the bottom. So we're going to have to rationalize our denominator. So we're going to multiply top and bottom by square root of 6 over square root of 6. So that's going to leave us with 7 square root of 6 in our numerator. And then on the bottom, square root of 6 times square root of 6 is 6 times 2 is 12. So there's cosecant of theta. We already know cosine was given as 5 over 7. Secant is a reciprocal, so that's just going to be 7 over 5. Right? If you want to, you can go ahead and put your cosine of theta right here if you're one of those people that likes to have all 6 listed for you. And then tangent of theta is going to be the side opposite over the side adjacent. So in this case, 2 square roots of 6 over 5. And our cotangent is going to be the reciprocal of that. So we flip that over and we have 5 on the top and 2 square roots of 6 on the bottom, which again will need to be rationalized. So we multiply top and bottom by square root of 6 over square root of 6. In our numerator, we end up with 5 square roots of 6. In the denominator, square root of 6 times square root of 6 is 6 times 2 is 12, just like we had before. So here are all 6 trigonometric ratios of this triangle. The next thing we're going to talk about is some of our special right triangles, the 45-45-90 triangle and the 30-60-90 triangle, which we're familiar with because we use these to find our ordered pairs in the unit circle. So first of all, when we look at the 45-45-90 triangle, what we already know, we've done this work already this year, is first of all, if it's 45-45-90, we can go ahead and we can label our angles. We know that if those two angles are the same, these two sides are the same. And because we're thinking about this triangle as being situated in the unit circle, we know that the lengths of the legs of our triangle are really the radius of our triangle. So in this case, it's going to be 1 and 1 here, right? And then if we do the algebra, we find out that our hypotenuse is square root of 2 because 1 squared is 1 plus 1 squared is 1. 1 plus 1 is 2. So c squared would be the square root of 2. So c squared would be 2, which means c would be the square root of 2. That's just your basic Pythagorean theorem. In a 30-60-90 triangle, if we go ahead and label these sides, okay, we know from our right triangle trig that the lengths of the sides here are going to be 1, 2, and the square root of 3. Okay, so when we take a look at just filling in this table here, if our theta is in degrees, 30, 45, and 60 would be our degree measures that we're concerned with in the first quadrant of the unit circle. But if we look at them in radians, 30 degrees is equivalent to pi over 6 radians. 45 degrees is equivalent to pi over 4 radians. And 60 degrees is equivalent to pi over 3 radians. But now we can use our triangles to take a look at the sine, the cosine, and the tangent of our angles theta. So at pi over 6, sine of theta, which is again the same as 30 degrees, if we look at our triangle, the sine of 30 degrees is 1/2. The cosine of 30 degrees is going to be the square root of 3 over 2, and the tangent of 30 degrees is going to be the square root of 3 over 3. At 45 degrees, or pi over 4, sine of theta is going to be equal to square root of 2 over 2. Cosine of theta is going to be equal to square root of 2 over 2. And tangent of theta is going to be equal to square root of 2 over 2 divided by square root of 2 over 2, which is 1. And then finally, 60 degrees, or pi over 3, we know that the sine of theta is square root of 3 over 2. We know that the cosine of theta is 1/2. And again, tangent is sine over cosine. So when we do square root of 3 over 2 divided by 1/2, we end up with square root of 3. Now we're going to change gears a little bit. We're going to grab our calculators and do a little bit of calculator use. So pause the video for a minute, grab your calculator. And the first thing that you want to do when you're using your calculator is make sure that you are in the right mode, either radians or degrees. So obviously, in example 1, if we're trying to find the sine of 17 degrees, we want our calculator to be in degree mode because that is the given measure. And once you're in the right mode, you just hit sine 17, enter. The sine of 17 degrees is 0.2923. In my second example, we're trying to find the cosine of 4. We talked about previously in the last section that if there's not a unit given on an angle, that you are to assume that it is in radians. So since it doesn't say degrees, then they are asking us to find the cosine of 4 radians. So we need to make sure that our calculator is in radian mode. We do cosine 4, and you should get negative 0.6536. And then finally, our last example here is in degrees. So we're going to go back to degree mode on our calculator. And if we are trying to find the cotangent, remember cotangent is the reciprocal of tangent, okay? So what you could do on your calculator is just do the tangent of negative 32 degrees and then do 1 divided by that value. You should get for your answer negative 1.6003. All right, if you are struggling with your calculator use, please talk to me in class so that we can clear up any confusion that you might be having about this. All right, the next thing that we are going to do is we are going to solve a right triangle. This is something that you did in geometry. Solving a right triangle means that we are finding measures of all 3 angles. Which there are 3. And the lengths of all of the sides, which again, there are 3, right? For this particular problem, we're given a picture here. We know we have a right triangle, and we know that this is a special triangle because the angle that we are given is 30 degrees. If that angle is 30 degrees, then this angle has to be 60 degrees. So we can use a special triangle to solve this triangle, right? We know, I'm just going to draw another triangle right here as a reference. We know from above that if we have a 30, 60, 90 right triangle, we know that the side adjacent to the 60 degree angle has a length of 1. the side opposite